Professor Ndam is Research Director at IRD, Adjunct Professor at the University of Ghana, Scientific Advisor at WANIDA, and Representative at IRD for Benin, Togo, Nigeria, and Ghana.
Thank you, Sylvie. Sylvie is my boss. She's the Deputy Director of my department, Health Department at IRD. So thank you, Sylvie. It's my privilege to be introduced by you. So I was asked to talk about one of the success stories, and I initially wanted to talk about the WANIDA, and you all know about WANIDA. WANIDA in itself is a success story. And after discussion with colleagues, they say I should maybe expand the talk Patrick gave yesterday on the placenta malaria vaccine development. So I have a couple of slides just to give an update on the advancing the clinical development of the placenta malaria vaccine. So as Patrick introduced yesterday, so we have like 40 million pregnant women living in malaria transmission area in Africa, and they are at risk of malaria during their pregnancies. And one of the main consequences of malaria during pregnancy, especially in primigravity, are the occurrence of low birth weight. And the low birth weight, as we know, is a major risk factor for neonatal mortality and morbidity. So the current tools to prevent malaria during pregnancy are not satisfactory, although they are producing some interesting results when they are properly implemented. So these, for now, are the use of bed nets and IPTP, so intermittent preventive treatment during pregnancy with SP. So the main problem with the implementation, the success of these tools are basically the low coverage. So women come to ANC very late. So the initiation of these strategies generally suffer from this late turnover on ANC. So based on this observation that placental infections already start before the second trimester of pregnancy, where most of these tools cannot be implemented, maybe because the drugs are not safe for the condition, or because pregnant women arrive very late at ANC. And studies show that even at 7 weeks of pregnancy, we already have placenta parasites in pregnant women. This is very, very early in pregnancy. And we also have the difficulties of preventing these early infections with drugs. And therefore there is a need to develop new strategies to offer a better coverage of prevention in pregnancy. And we thought the vaccine would prevent a large number of these low birth weight that are associated to placenta malaria and save many lives. So the struggle now is to develop the vaccine based on the mechanism that Patrick Duffy and colleagues pioneered by identifying the receptor in the placenta that the parasite used to sequester. So based on that, there was intensive research to identify the ligand, so the parasite molecule that interact with this particular receptors. And this molecule, the VAR2-CSA, one of the variant surface antigen that the parasite express on the surface of red blood cells, were unanimously characterized, and this is named VAR2-CSA and now constitute a candidate vaccine for placenta malaria. So many teams have been now working, trying to use the vaccine, the VAR2-CSA, to develop vaccine. And my team is actively involved in this research. So the concept to develop this placenta malaria vaccine is based on the fact that nulligravidy, so women who have never been pregnant and living in Africa in a malaria endemic area, when they get pregnant, they become highly susceptible to infections. And these particular infections coming at first pregnancy a particular phenotype because they sequester in the placenta and they escape the pre-existing immunity because they have never seen such parasite with this phenotype. So they sequester in the placenta, causing those deleterious effects to the pregnancy, so both fetus and the mother. And during successive pregnancy, women acquire immunity that protects the placenta from this type of infections. So the observation led to the fact that we could, if we understand this mechanism, we could artificially reproduce in a vaccine to protect pregnant women at first pregnancy, and then now to overcome all the difficulties of preventing first trimester infections. So the vaccination with this molecule would then drive this protection by using this PFEMP1, so the VAR2-CSA parasite protein. Using some domains of this PFEMP1 could induce antibodies in primary gravity that will be able to interrupt or block this placenta sequestration, so the interaction of infected red blood cells with the placenta receptor CSA. So this is the rationale of the vaccine. If we can develop such a vaccine that induces adhesion blocking antibody, we'll be able to prevent placenta sequestration of infected red blood cells, and then the parasite, the infected red blood cell, would just be filtered by the spleen. This is the main rationale to develop this vaccine, and the criteria, the no-go criteria in any vaccine development attempts based on VAR2-CSA. So two vaccines, two candidates were derived from the VAR2-CSA and tested in the field through the phase 1A and 1B. And these candidates were PAMVAC, the candidates we are developing with the University of Copenhagen, and the PRIMVAC that is developed by another team in France, the INSEM. And both vaccines tested in distant phase 1 and phase 2 clinical trial in non-exposed and exposed pregnant women, gave some encouraging results. And I was just showing here what Patrick showed yesterday, the construct corresponding to PRIMVAC and PAMVAC. These are in the N-terminal of the VAR2-CSA molecule, because it was very difficult to develop the vaccine with this 350 kilodalton protein. Is a very large protein. Due to this technological constraints, it was necessary to identify the area that concentrates epitope with inhibitory antibodies. So the N-terminal was identified, and these two candidates were derived. So they were tested in Germany and in France in phase 1A, and in Benin and Burkina Faso for phase 1B. And the main results for these two candidates show that they were safe and well tolerated, both in phase 1 and phase 2. And PAMVAC and PRIMVAC were immunogenic in all the participants, with high level of antibodies when the vaccine was formulated with GLA-SC compared to alidrogel and the GLA-LSQ. So the vaccine generated reacting antibodies with homologous VAR2-CSA expressing parasites. So the PRIMVAC was based on 3D7 strain, and the PAMVAC derived from FCR3 strain. So when we analyzed the antibody response induced by vaccine, there was a high reactivity with homologous parasite on the native protein. But unfortunately, the binding and the cross-reactivity was limited. So meaning that we need to improve this vaccine before moving them to phase 2 And what we did in Benin was to collect the parasites from pregnant women, sequence them, and analyze the N-terminal part to see how diverse is the antibodies and this particular vaccine target. And what we observed was that the VAR2-CSA variants could cluster in 3 different clades. So the 3D7-like clades, the FCR3-like, and another particular clade that is WR80-like. And the particularity of these variants was that they were only found in multigravidae who were infected, suggesting that there might be some immune evasion with the VAR2-CSA antigens, and we need to anticipate and cover this. So we selected one of the member of these 3 clades and expressed in our lab in Paris. These are the 3 different clades, the 3 members that we selected and expressed in the E. coli, and try another a strategy of combination using the CVLP, so the capsid-like particle. So with the experience, we thought that VAR2-CSA being a membrane protein, the presentation of the antigen might also be very, very important to consider in the formulation. So expressing them on a structure that can let them appear as they are on the surface might be important or essential. So that's why we went to this capsid-like to attach our different variants on. So we were able to put in place a strategy to assess this combination of the antigens and assess their efficiency and their distribution on the surface of the viruses. So this is what the slide is showing here. And the colleague in France, in my lab in France, who are involved in this are Isabelle Goguet, Magali Blo, and Nicolas Lulliou, who are structuralists and molecular biologists. So what we did now with the new funding we got from GIT and the EU was to address 2 different objectives. The first being to assess the immunogenicity of the new vaccine, new formulation, the capsid-like, that is composed of a mosaic particle with the 3 different antigens that I show. And we have also been trying to identify conserved epitopes, both C and T, B and T cell epitopes in the conserved area of VAR2-CSA within the binding pocket, to also put them on the surface of the VLP. And as a mitigation policy, we also put the full-length VAR2-CSA on the VLP to now induce antibodies in small animal and test the properties of the functionality and the level of immunogenicity. So in the second objective was now to select using the go-no-go criteria, that is mostly the ability of the antibodies generated to block the interaction with CSA of many VAR2-CSA expressing parasite, so the heterologous parasite. Sorry, you don't see the slide anymore. Okay, so I'll just continue. Okay, so this is what we are now doing, because the objective is to move the MOS formulation into the GMP manufacturing, and then take it into the clinical trial of phase 2. So we got a funding from GIT from Japan, 3.6 million euro to do this, and then an additional funding from EU through the Horizon Core, 10 million euro with the EVI, to take the formulation, the combination into the phase 2 clinical trial. And we just heard that EVI was able to secure some funding from the Netherlands to take the best vaccine to phase 3. So I think this is one of the success story I wanted to tell. There are efforts in advancing this development of vaccine based on VAR2-CSA that will probably need to be tested in Africa and within the WANIDA members. Yeah. Thank you.
Thank you very much, Lucas, for this interesting presentation.
Sorry that you couldn't see all the slides, but if you have questions, I'll be there during the break. We'll discuss. So.
Yes, just we are going to continue with the second speakers, and if you have any question, we could take it after the second speakers. So thank you very much. So I have the privilege to introduce the first keynote speakers who is online. So this is Dr. Yo Pidiako. He's a Ghanaian immunologist currently working as a research fellow at WACB. And in 2020, he founded the Yimaki Biotech, I hope this is correct, which is an immunogenomics startup based in Accra. And he's telling us about these stories and these adventures. So thank you very much. Is it working online? No. There is some technical problem, I think. Okay. Okay, so if we have 5 minutes, we can we can have a few questions for Nikes, so this is perfect. Is there a question in the room? Please, yes? Here? Okay, sorry, you need a micro.
Nikes, how does the activity of the anti-sera compare to just women's sera, what's naturally acquired? Can you compare the activity that women naturally acquire to the activity of what you're getting with the vaccine?
Sure, yeah. So this is what we're doing now, and yeah, I had to elaborate a bit on it because we are collaborating with NIH. So we have been comparing the ability of the antibody induced in mouse, the ability to inhibit binding from VAR2-CSA heterologous parasite, and for now it is like the cross-reactivity and the cross-immunity properties very, very good compared to single variant attached to the same VLP. And the next step was we were using the multi-gravity anti-sera as a control, and the profile is pretty close to that of multi-gravity. And what Patrick suggested yesterday during the discussion we had, personal discussion we had, was to use this combination, this CVLP, to affinity purify antibodies from pregnant women, sera, and compare their cross-reactivity or cross-inhibitory on the sera parasite that we have been establishing in vitro. Yeah, we are planning to do that next time, and that will be in collaboration with one of you guys. Yeah. Yeah.
Yes, there is.
Yes, hello. Thank you for a great talk. I just wanted to know, you identified 3 different clades in parasites circulating in Beninese women. Are you able to tell us the distribution of those 3 3 clades in the African population.
Yeah.
And then also, we knew that at least majority of those parasites were NA54 circulating. Now with these 3 clades, what are identified in these women from Benin?
Yeah.
How sure are we that representing this in a vaccine construct could elicit cross-reactivity?
Okay. So we did some bioinformatic analysis using sequences from Benin, and based on that, we could, based on the VAR2 CSA, right? So the 3D7 were like 40% of the parasites circulating in Benin, and 40% were FCR3-like parasites in the genetic background on VAR2 CSA. And this third WRAT were representing 20%. We collected all the VAR2 CSA sequences that are available online, and we were able to see the same distribution. So there is no geographical bias on any of these 3 clades. So they are 20%, the third clade 20% in all the sequences that we collected from Thomas Otto, and also the sequences we generated in Benin and in Eastern Africa. So we still find the same distribution, 20%. So I don't think there is any risk based on the geographical bias. And this cannot also explain that these variants emerge in Benin. They are almost everywhere, but they are not dominant variants. But apparently, as they occur in multigravity who already have anti-VAR2 CSA immunity, probably they are rare and they come after. So maybe they don't have a strong fitness compared to FCR3 and 3D7. That's why they come late. And we need to consider when we develop the vaccine that we shouldn't leave any window open to such variants who emerge later. Thank you. I think the technical issue is now over.
Yes, technical issues are now resolved, so I'm very sorry. I'm sure there is still a lot of questions. We can continue the discussion during the break. And we are going to switch to the second keynote speaker who is now ready. Thank you. Yes, we are not hearing you. Sorry. No, sorry, it's not working. Your micro is not working, so we cannot hearing you. I think it's okay now. Please speak. No.
Hello?
Yes, it's working. Perfect. Let's go.
Okay, can you hear me now?
Yeah.
Okay. All right, thank you very much. Thank you, Madam Chair, for the introduction, and thank you to the organizers of WANIDA for the invitation to speak. I'm sorry I couldn't be in Accra for the conference. I'm currently speaking to you from Cape Town at another workshop. So I was asked to speak sort of in regards to lessons learned from the pandemic, and I've tried to weave in a discussion about what I see as the role of biotech in accelerating development in Africa, and give you a bit of an example from our own situation in Ghana. So I'll start off with a bit of a question. I don't know if anybody would recognize who these people are or what the company they founded is called, but it was founded by a married couple, two scientists, in 2008, focused at that time and actually still on new approaches to treat cancer, including development of anti-cancer vaccines. Between 2008 and 2019, they raised over $500 million in investment for their company. But as you can see, their revenues were relatively low, about 60 million in 2017, all the way to 2020, where they went up quite sharply to 482 million euro. And then in 2021, their company made revenue of 18.9 billion euro. So I don't know if there are any guesses in the room. I'm sorry I'm not there to do this interactively, but if there are any guesses in the room about what this company is called. If you guessed BioNTech, then you are correct. This is the story of BioNTech, a German startup, biotech company that is now rivaling some of the biggest pharmaceutical companies for revenue and for actually market capitalization. So this is an example of a massive success story, and I'll try to draw parallels to what I think, the opportunities that biotech presents. But BioNTech, as you may be aware, was responsible for one of the anti-COVID vaccines, the one done in partnership with Pfizer. And in actual fact, BioNTech developed the technology. Pfizer was brought in to help scale, provide scale and provide manufacturing capacity and distribution capacity. But the IP and really the intellectual property and the discovery that went into the COVID vaccine was all developed by BioNTech. So let's come to Africa now. When we think about investments in research and development to result in companies like BioNTech, we have to ask ourselves what is happening on the African continent. So in 2016, Africa accounted for about only 1%, about 22.3 billion of global investments in R&D. That is in contrast to the $2.3 trillion invested in R&D in the same year. And what I've tried to do is show you, I don't know if you can still see my screen. Yes, you can. Okay. What I'm trying to do is show you what that looks like drawn to scale. So I couldn't fit 22.3 billion in a dot small enough to scale, but you can see the dot on the far right is actually the difference between Africa's investments in R&D and what you see on a global scale. So you can see we really are almost a negligible component of global R&D investments. And even this negligible portion is highly concentrated in 3 countries, Egypt, South Africa, and Nigeria, which together account for 65% of Africa's investments. Now, why do we keep talking? You hear a lot of politicians these days, economists, and some scientists talking about the need for greater investment in research. There's a term called GERD, which stands for Gross Domestic Expenditure on Research and Development. It's a term the World Bank uses and many development agencies use. Now, GERD refers to the total amount of money a country invests in research. And this is, I should mention, this is not just government investment. This is total investment from both the public and private sectors. There's clear evidence that for every 1% a country's GDP increases by 2.2%. So in an age where many countries, including in Africa, are striving for double-digit growth, it seems like the natural way to achieve this growth is to increase GERD. Now, if you look at most developed economies, their GERD is typically exceeding 2% of their GDPs, and some of these countries have rather significant GDPs. Unfortunately, in Africa, nearly all our countries invest less than 1%. You can see from the graph, again, from this BMJ article, where each of the countries stand. So you can see Egypt, Kenya, and a few countries are at the top. Even they are somewhere below 1%. Ghana is between 0.2 and 0.4%, and you can see countries like Algeria and the DRC are less than 0.1%. So in general, the story in Africa is not a very good one. Even our biggest even countries like South Africa are hovering somewhere around 1%, whereas the global average is 1.7, and countries like the United States are between 2 to 3%. Now, when we drill into these numbers further, we also realize that majority of the R&D investments in Africa are actually from the public sector. They are from government. So with the exception of South Africa, most of the countries on this list, you can see that the largest proportion of R&D investment is actually occurring in the public sector. So it's government investments. But most of the time, when you look deeply at these government investments, it's not really money from the government. It's overseas donor money that the government then allocates to R&D. So even these funds that are supposedly public money, it's actually not public money. It's external overseas aid that is then apportioned and allocated to R&D. So in general, it paints a rather sad picture in Africa where we don't do that much investment in R&D, and the little we do, it doesn't involve the private sector and really is dependent on overseas support. Now, if we turn our attention to what happens in the United States, which arguably is the world's largest economy and has great emphasis on R&D, you find that the U.S. spends in 2019 spent $667 billion total investments by the U.S. in R&D. But if you look at where that investment came from, you actually realize that 72% of it came from business. Only 20% came from the federal government, and then a further 8% from institutions, higher education institutions and nonprofits. So 72% of U.S. investment, so U.S. GERD, is actually from private sector and not from the government. And if you actually look at who is performing the R&D, once again, 75% of R&D is performed by private businesses. Only 9% is performed by the government, so that would be in institutions like the NIH and others. And then you have higher, universities and other NGOs that perform 16%. So 3/4 of R&D productivity from the United States actually occurs in the private sector. So you can see how straight away Africa has a massive problem, because our GERD is low, but probably you can attribute that low GERD to the fact that we don't have adequate involvement of the private sector. We are putting all the emphasis on government, many of whom do not have the resources required, and we are excluding or not taking advantage of what the private sector could do. And in fact, it is a well documented fact that no country in the world has ever crossed a 1% threshold of GERD without private sector share of GERD surpassing the public sector. So basically what that means is you have no hope of achieving the target that the Africa Union, for instance, has set for African countries to contribute more than 1% of our GDPs to research and development, unless our public sector share of that investment outstrips what we are expecting governments to do. So just to recap, the problem we have in Africa is low investments and a low proportion of our GDP being invested in research. Now this leads to what many of us in academia would refer to as a brain drain. Institutions like WACPIP and many of the WANIDA partners have raised great funding to train the next generation of scientists, but unfortunately, there's significant attrition. So we lose about $2 billion a year just in healthcare sector alone through talent leaving the continent. So one may ask, all the emphasis on training over the last 10 to 15 years, whether it has actually achieved the necessary impact. If majority of the people we train with masters and PhDs end up leaving the continent, then we're actually doing the training for Europe and North America, and we're actually making our brain drain much more expensive. Because before we used to lose people after high school, now we lose people after a PhD. So we have to ask ourselves whether we're actually making the situation any better. And so I think the real challenge we have is how can we turn our science to create jobs? Training is important, yes, but training without an environment, a conducive environment to absorb the capacity we train will actually result in a much more expensive problem. And ultimately, losing those people means then Africa continues to produce only 1 to 2% of the global R&D output, even though we account for almost 15% of the world's population. So the question then is, what's the solution? And I believe this is where biotech can begin to play a role. Obviously, biotech is not the only solution, but I believe that, especially within the life sciences, private research driven by biotech creates jobs. I've said this before, that universities do not create jobs. Universities create future unemployed people. And so universities need an outlet for the talent they create. Otherwise, that talent will drain out. So the biotech sector, if developed properly, can provide exciting and well-paying jobs for the talent that we train, and ultimately results in retaining that value locally. It's also possible for biotechs to innovate and translate for impact. Exactly what we saw with BioNTech, developing new technologies, mRNA technologies, initially for cancer, that they repurposed for COVID. Without a BioNTech, we may not have, without biotech companies that can innovate quickly, we may not have had the results we saw with the how quickly we're able to adapt and respond to the emerging challenge of COVID. So Africa needs its own BioNTechs. Africa needs biotech companies that can attract both local and international investment and talent, and ultimately scale. And so I think biotech fits into this ecosystem. We currently have government, public sector players, healthcare providers, global partners and funders, and then global pharma industry, all working together to try to improve health in Africa. But without an African biotech ecosystem that can draw all these partners together and scale up the activities across the continent, I think we find that we are struggling to achieve any real tangible results. So let's take a look more closely at the African healthcare sector. Just a few facts and figures from a report that came out at the end of last year, sponsored by the USAID. So Africa makes up 16% of the world's population and yet carries 23% of the global disease burden. I'm sure everybody in the room and listening to me knows these numbers. And as I said, we only account for 1% of global health expenditure and R&D output. Now, COVID highlighted the fragilities, and I'll get into that in a couple of slides. But when you think from a market perspective, Africa remains highly fragmented. And so that creates challenges when we think about investment. And so I think we need to be smart in the way we try to build biotech and the way we try to attract investment. But the biggest challenge is that by 2050, we expect Africa to be home to 25% of the world's population. Africa's population is expected to double in that time. So if you think we have problems now, imagine having twice the number of people. Imagine a Nigeria that has 400 million people instead of 200 million people. Imagine a Ghana that has 60 to 70 million people instead of 30 million people. And you can very quickly see that if we don't do something drastic, we'll actually have a very, very bad situation on our hands. So where does the money come from to fund biotech and R&D? Now, Africa has had some success over the last few years to attract overseas investment. In this case, I'm not including government investment like DFIs, so direct finance institutes, or overseas aid. In this case, I'm showing only private equity and venture capital investments in Africa. You can see, once again, there are only a few markets that attract most of the money. Since 2016, this has been about $2.2 billion in just private investment in the healthcare sector. In total, Africa typically attracts about $5 billion. Last year attracted $5 billion in overseas investment across all sectors. And that is set to increase to about $7 billion in the next year. But you can see Egypt, Kenya, Egypt, Nigeria, and South Africa, the three big giants of Africa, account for majority of the investment, with some investment going to Ghana and Kenya. And if you look at where this investment has gone, once again from this USAID report, you find that a lot of it goes into manufacturing of medical commodities. You can see Aspen, the new South African company that is producing vaccines, and a few others. So a lot of the investment goes into manufacturing. But we are also seeing an increase in biomedical research investments, as well as in the healthcare financing, as well as health data and analytics fields. And you can see a few of the startups, the African startups represented at the bottom of the slide. I'm proud to say, including my company, Yamachi. So I've sort of been harping on the fact that private funding for R&D in Africa is generally low. And actually, if you look at it, majority of it goes into supply of general healthcare products. Now, while these are important, they actually do not generate IP. When you think of BioNTech, the reason their valuation and their revenue jumped so astronomically is because they own the IP to the vaccine. If you simply manufacture products, yes, you may make some revenue, and these are important services to provide, but you don't generate IP. The only way you generate IP is through research and development. And you can see that only 5% of private funding for R&D has gone into this sector. So this shows the current immaturity of our private R&D sector in Africa, where we have very few companies, and the few companies that are there are not attracting a lot of money yet to really fuel their investment. As much as BioNTech made 19 billion euro in 2022, they'd already raised $500 million before COVID hit. So there is a need for significant capital investments in biotech to allow these companies to actually take advantage of opportunities when they present themselves. So this pie chart has to change with more investment in R&D, in addition to investments in supply of general healthcare products and services and other pharmaceuticals. So the point I've been trying to make, and I hope it's relatively clear, is that we cannot simply focus on academia if we want to truly transform economies in Africa. We need to invest in a biotech sector that can take innovations from academia, can absorb talent trained in academic institutions, and advance that towards big pharma. We don't necessarily need to have big pharma in Africa right now. There are only a handful of big pharma companies globally anyway, but big pharma can be drawn to invest in Africa through the activities of biotech. Similar to the way BioNTech drew in Pfizer, wouldn't it be great if we had an African equivalent of BioNTech that could partner with a company like Pfizer or another big pharma to deliver a product? That in turn drives investment into the African continent and helps us to grow our ecosystem. Global biotech is a $700 billion industry. Unfortunately, Africa and the Middle East currently account for only 18 billion. That number needs to change drastically if we are to see the gains that we hope to see. So let's turn our attention back to COVID and think about maybe some of the lessons we can learn and how perhaps what we should and maybe should not do, at least based on the evidence before us. So this is a map that I'm sure is familiar to everybody. The fact that when it came to COVID vaccines, even after the work of companies like BioNTech, AstraZeneca and Oxford, Moderna and others, where we had an unprecedented drive to develop a vaccine for the globe, Africa was left behind, and vaccine coverage at the end of 2021 was this pathetic situation where the rest of the world was almost fully vaccinated and Africa was barely vaccinated. And this was largely a result of lack of access to vaccines in most African countries. Now, this Gavi report that just came out in November of 2022 demonstrates in stark contrast the lack of vaccine production capacity across Africa. We have a population of 1.4 billion, and yet we have production of 0.03 billion, compared to the Americas that have a smaller population, around 1 billion, but have vaccine production capacity that is 5 times their population. Europe, a similar example, with more than 5 times their capacity, more than 5 times the vaccine production capacity compared to their population. So this is, in fact, Asia Pacific is also similar. So Africa is the one region in the world where our population far outstrips our vaccine production capacity. And if you look at where the vaccines in Africa come from, majority of them come from Asia and Europe. So Africa does not produce any of the vaccines that it actually consumes. So in response to this, we've heard a lot about governments across Africa announcing grand plans to improve vaccine production or vaccine manufacture, including Ghana and several of the countries represented by WANIDA. Now, this is not a bad thing, but I think it has to be taken at times with a certain amount of caution, because while many of these announcements have been made, it remains to be seen how many of them have actually gone into development. And when you understand the capital requirements to establish this capacity and the business case to support these industries, we have to be very cautious in how we deploy capital. Does Africa need every single one of these countries to make vaccines, or does there need to be a more strategic approach in order to prevent these factories from becoming defunct? And there are warnings from COVID that we have to be careful. BioVac, who I had the opportunity to actually visit yesterday, is a partner with Pfizer to produce the Pfizer vaccine. There have been stories about how BioVac has had a lack of market for the vaccine, the capacity that they have generated. The Johnson & Johnson vaccine produced in South Africa is another example. So just simply producing vaccines does not necessarily mean there's sufficient market for them. And we have to be very careful that we don't create a problem where we produce too much vaccine and don't think through the market conditions. So the first thing to ask is, who buys Africa's vaccines? Majority of vaccines deployed in Africa are bought by Gavi. Now, that means that Gavi has to give assurances that it will purchase African-produced vaccines if African vaccine manufacturers are to succeed. And the first question is, what determines Gavi, whether or not the Gavi can pay for a vaccine or can offer an offtake to a vaccine manufacturer? As you can see here, majority of the countries that we live in are Gavi countries. So basically, our governments don't buy the vaccines directly. They depend on vaccines provided by Gavi, who purchases them based on its own criteria. So you have the issue where if we don't have a continental strategy, we end up with a high price, what's called a high price, low volume trap, where you are producing, your cost of production is high, so your vaccines are not competitive with, for instance, Asian manufacturers, and yet you don't have the volume to drive down your costs. The biggest challenge to African manufacturers is getting WHO pre-certification. Gavi will only purchase vaccines that have WHO pre-certification, and attaining that level of pre-certification or that level of quality assurance takes a number of years. So just because Ghana or Nigeria begins to produce a vaccine tomorrow, however unlikely that might be, even if we were able to do that without WHO pre-qualification, we wouldn't be able to sell to Gavi, which means we wouldn't really have a market for our vaccines. So it's not just as simple as just producing vaccines. We have to think of the market conditions. And in fact, in this Gavi report, I don't have time to walk through all of it, but you can see they classified certain vaccines as ones that African producers should target and others where African producers probably stay away, because adding a new supplier would probably deteriorate our market health. So you can see cholera, Ebola, malaria are ones that there is good rationale for regional production. B and C are vaccines that require a bit more R&D. So once again, simply building a fill and finish factory is not going to cut it, because what is called for is optimization and modification, and in some cases, development of new vaccines, all of which require R&D beyond simply vaccine end stage sort of packaging or fill and finish. And then there are certain vaccines like polio and measles where there is absolutely no need, based on this report, for geographic or for local production. There is enough in the system that if we sorted out logistical issues, everybody would have access to. So I'm going to switch gears just at the end of my remarks to just tell you a little bit about what we're doing at Yamachi. This is we are a small biotech startup based in Accra. A bit like BioNTech, our focus is on cancer, and we can speak more about why cancer. But we raise money from Silicon Valley as well as some African investors, got some support from the Gates Foundation. And really the problem we are solving, I don't have too much time to go into it too much now, but is a lack of diversity and a lack of diversity in data. So majority of genomic data is from people of European ancestry, which severely limits the efficiency of precision tools developed for cancer. Typically, people of African descent have the least efficient responses or the worst outcomes based on the fact that majority of the drugs and, in this case, new precision algorithms are designed using data that does not represent them. So at Yamachi, what we're trying to do is tap into Africa's richest resource, which is human genetic diversity, and use that as a feedstock for drug discovery, hoping to identify new targets for cancer that can attract overseas pharma to develop them into drugs that will work in Africans, but also work in people all over the world. So I'm happy to speak more about this at a later time, but that is sort of the Yamachi approach. We've picked cancer because we have a growing burden. Despite all the focus on infectious disease, cancer is killing more people in Africa, for instance, than malaria already. And the trajectory is not a good one. It appears that the burden of cancer is growing rapidly across the continent, and there is a need for us to begin to address this in a very strategic manner. From a business perspective, cancer is big business in pharma. 30% of their farm pipeline is focused on oncology, and so we felt that it made sense from a business perspective to try to be a biotech company that was doing something about cancer. I'll skip through this, but basically we're building a genomic database of cancers, the world's largest genomic database on cancers among African people, and then trying to use machine learning and computational biology to identify new targets. We built collaborations across the continent. We currently have partners in 8 African countries, and as well as technical partners in the US, in Australia, and in Europe. But in relation to this talk, what Yamachi has allowed us to do is to begin to build into the ecosystem in Ghana, tapping into WACBIP, as well as our overseas collaborators, the Ghana Health Service, and other players in the ecosystem to begin to try to solve local problems. And so when COVID hit, we wrote a grant to the Gates Foundation, who typically don't fund cancer research, but they do fund research. And so in partnership, with WACBIP, we submitted a grant and actually were awarded a grant for what we call the Heritage Study, where we are trying to understand vaccine responses among Ghanaian population and comparing it with the UK population. This is one of the most in-depth explorations of the mechanisms of vaccine response in the African population, and we hope it will begin to answer questions about why certain vaccines appear to work better in Europe than and when deployed in Africa appear to work a little bit less well. So just to finally finish up, some of the reflections post-COVID, I believe that vaccine manufacturing alone is not enough. It's going to be a much more nuanced situation. We need a continental strategy. It is not enough for each country to try to build its own vaccine factory. Most likely many of those would fail if we took that approach. And it's not just manufacturing. It's not enough to focus on fill and finish approaches. We actually need to invest in R&D. It may be a longer process, but we need to move now to prepare ourselves for another pandemic down the line. Our governments are still too slow to act. Ghana has signed a Vaccine Institute bill, but that bill, I believe, has still not been fully signed into law, and it's not entirely clear what that bill will mean. I think in general, efforts have been made on a continental level in terms of pathogen sequencing and understanding the pathogen, but we need to now transition into proactive steps to actually develop capacity for discovery research and then also further translational development of that discovery research. Our funding is still external. Of course, investments also will come from outside, but the advantage of building industries in Africa is ultimately those industries can generate revenue that will hopefully begin to break this cycle of dependency. In line with that, we learned we cannot count on the West. We need to become more self-sufficient. But once again, self-sufficiency will probably begin in the private sector. We need to understand that governments cannot do it all. And without a thriving private sector, we will never be self-sufficient. So I think we need an innovative long-term planning. We need to focus on sustainable development and not short-term buzzwords, not things to gather political points, but we need to think carefully about what it means to build biotech, what it means to build research and development capacity, and what that capacity should look like. The future is bright if we take advantage of it. In 2022, Africa was the only region where VC capital raised did not decline. Most parts of the world saw a decrease as macroeconomic conditions changed. But in Africa, people still invested, even though the investments relatively small compared to only 1% of global VC activity. But if you think that in 2010, Africa raised only $200 million in VC money, and in 2022 raised about $5 to $6 billion, you can see that there is movement in the right direction, and we need to keep pushing. A number of local African VC funds have been raised. We need to help them to see that it's not just about investing in fintech and other sort of app-based solutions. They need to invest in life science R&D. That is on us as scientists to help them to see that there is value in placing those long-term investments. But I believe that funders can do a lot to catalyze this growth. We could call on international funders to begin to look at more creative ways of deploying capital, not simply issuing grants, but making strategic investments in the private sector. And ultimately, we should understand that 1% of GERD that we are all striving for, that the AU made a declaration on over 10 years ago, is never going to happen unless our private sector pulls its own weight. And finally, governments can make this more attractive by creating incentives. They may not have the resources to actually fund startups, but they can make the environment more conducive. Currently in Ghana, we've had the import duty waiver has been suspended due to the economic issues, and that is placing a huge burden on many companies. That is something that should be thought of, should be perhaps reviewed, because it makes Ghana less attractive to foreign investment. And many companies will try to go to places like Zanzibar and Zambia, who are making it much more attractive for companies to set up and to invest. But beyond that, to all the scientists in the room, both young and old, I think some of us need to be entrepreneurs. We need to get out of the classroom, get out of the lab, and get out there and try to translate our science, and also get into policy-making positions. We need some scientists to get into policy-making positions so that our voice is heard, so that conditions can be made such that African science can begin to solve its own problems and truly take advantage of the great wealth that the continent has to offer. So thank you very much. I appreciate the opportunity to speak. And if there's time for questions, I'm happy to take a few. Thank you.
Thank you very much for this very exciting presentation. There is this raise a number of very interesting perspectives for the development, the role of biotech and the development in the development of the health sectors to tackle the health issue for Africa. So I'm sure there will be a lot of questions in the room. So is there a question for the speaker? So there is, I don't see any, yes, there is one question here.
Yeah, thank you so much for the wonderful presentation. I think that we need more of such intervention. The last time I heard of such talk was in South Africa during the Bio Africa Symposium. That was, I think, sometime last year, towards the end of last year. I think biotechnology is one of the topics that we tend to neglect. And I think I like very much the last statement that scientists need to become, to also be entrepreneurial. Now, it happens very common that, we publish papers, and those papers are used by other people to make products. And we ourselves, we did not use those results that we obtained through our research to turn, the results of the research into products. And I think that this is also showing what Dr. Ndam was talking earlier, to be able to turn the results of the research into products. So I think that I would like to, really congratulate you for the initiative, that you have started. And what I wanted to ask was, what advice, would you give to, young scientists, upcoming scientists, African scientists who are, interested in creating social companies like yours? I think that, the presentation was very, very useful. Thank you so much. I think I've learned a lot. Yeah, thanks a lot.
Thank you very much. I appreciate the comment. In terms of advice, I agree with you. I think young, African scientists, young or not so young, we need to begin to ask ourselves, what are the problems that need to be solved? And then try to understand, come up with solutions. I think we are very good at, like you said, writing papers and coming up with strategy documents. But I think we need to move beyond that now to actually try to implement. And so in my journey, I've found that when I define the problem, even if I don't have the answer, once I've defined the problem, I'm able to find help. I'm able to find expertise in other sectors to help me understand this problem. So what I've done with my company, my team is very multidisciplinary. It's all African, not all Ghanaian, but all African. And we each have unique skill sets. One of my co-founders worked in finance, used to work at Morgan Stanley. He's an investment guy. He doesn't know anything about biology, but he knows a lot about money and how to run a business. So I would encourage my colleagues who are interested in following this route is, first of all, define the problem and define how you think you'd like to address it, but then pull together a coalition of people who have expertise that you don't have, that you can learn from and that you can get advice from. I got a lot of advice from a lot of people before I started this journey, and a lot of it has proven to be extremely useful. So I think it's about identifying the problem, defining it, getting advice, but the final piece is have the courage to try. Many startups fail, but many startups succeed. And you may have bumps along the way, but the most important thing is to try, learn from your failures. I think it's Elon Musk who says, fail fast, so that you can continue. But don't be afraid of falling. And you may just you may just change the world.
Thank you. This is a very positive message for all young researchers here. Other question? Yes.
Hello. Yeah. Thank you so much for the talk. As a young guy, I've also learned so much. I just want to ask, what is your idea of a favorable ecosystem for a biotech company in Africa? And how does that favorable ecosystem helps academics? Thank you.
Thank you, Godwin. Yes, so I believe a favorable a favorable ecosystem can have a few a few characteristics, and obviously what makes it favorable for one type of business may not be exactly what is favorable for another. But I think at the very high level, we need an environment, first of all, where there is there are incentives to help us to grow. What I mean by that is, there are a lot of things the government can do to provide tax breaks. For instance, in our line of business, when you import a piece of scientific equipment, it would be great if you had a tax, you had a discount or a waiver on duty. Many countries do that to encourage small businesses. Also, the regulatory framework would be good if the regulatory framework can begin to grow to understand biotech. When you run a biotech lab, it's different from running a clinical diagnostic lab or a hospital lab. And so we would need our regulators to understand differences so that when they regulate us on the right metrics and not metrics that may not fit us entirely. Also, a good ecosystem will include the academic institutions. It would be great for academic institutions to understand the value of biotechs and to encourage their students to look for internships. In fact, go out of their way to try to encourage companies to take students on internships. This provides companies with hopefully good talent in the door, but also provides great opportunities for students to learn. So I think there are a number of things that can be done to establish a key ecosystem that is favorable. But I think, as with most things in business, one of the first considerations is finance. Both government making it easier for businesses to providing incentives, but then also finding ways to attract investment. Maybe using opportunities when the World Bank comes knocking to actually suggest to the World Bank that perhaps they can create programs that would be invested into small companies. So ring fencing funds for investment into small enterprises in the life sciences to foster and catalyze their growth. Many companies in the US and in Europe have benefited from government grants or sort of public support to get them going. So I think all of those things would help to contribute towards an ecosystem that gives young companies the best chance to succeed. And ultimately, their success, I believe, will catalyze further growth and ultimately lead to the development of our economy.
Thank you. Okay, maybe we are going to switch to the next presentations. Thank you very much again.
Thank you.
So it's my pleasure to introduce now Dr. Peter, Kjo Kashi, if I'm correct. Sorry again. And he's Deputy Research Director at WACBIC at the University of Ghana. And is he here? Yeah, okay, thank you very much. So he's going to speak about the evolution of SARS-CoV-2 research at WACBIC. Thank you very much.
Good morning. All right. It's a pleasure to be here this morning with all of you and to continue this program. And I'd like to just share a few snapshots on some of what we've done at WACBIP. And the title I chose for this presentation is The Silver Lining, the evolution of SARS-CoV-2 research at WACBIP. But it's really the evolution of the research program at WACBIP. That's why I use that term. And I always tell people that COVID has been good to us. Of course, it's been a dark cloud, but we were able to use it as a tool to basically evolve. And so I'll give a few lines about WACBIP, because in my current position now, whenever I give a presentation, I have to also represent my center. And WACBIP is an African Center of Excellence that was established in 2014, and it was with faculty from Department of Biochemistry, Cell and Molecular Biology, with some faculty from Noguchi, and it's really grown from that position to WACBIP that led the coalition known as WANIDA now. And the whole point of WACBIP was to be a research training center and to train the next generation of scientists with a vision to be a sustainable center of excellence and a global hub for tropical disease research. And we sort of built, or we are trying to build this on being anchored by technology hubs. And the idea is that if you focus on building up your hubs or your core areas of knowledge, then it allows you to really transition to do multiple things. And so we've set up a few hubs. We have flow cytometry, next generation sequencing. I'll mention those two because those two will feature in the talk. And actually, at the onset of the pandemic, we were just building up our next generation sequencing hub. And we had not yet, at that time, generated any, it was more for malaria plasmodium sequencing, and we had not yet generated any sequences from there. But we took advantage of COVID too, because we had this built up infrastructure to really fast track. And so over the period of the last 3 years, we've really done the full gamut. We've started with serological studies, and I'll show a little bit on that, transitioned to sequencing and molecular epidemiology, and now we're doing, we did transition also to doing work on the virus and pseudovirus, and we've now moved to do viral immunology. All along, we're still doing the serology and sequencing. And we published just recently, our first paper was published in 2021, which was one of the first molecular epidemiology papers of COVID in Africa. But recently, we also, as part of WANIDA Consortium, we got some funding from Rockefeller to really do a large-scale sero and epidemiology research across a few West African countries. And this is a paper from the West African, from the Ghana branch of that, where we basically tracked the way that the virus has evolved in Ghana since 2020, and this is an ongoing graph. An updated version would be all the way up to 2 months ago when we really stopped seeing cases. So basically, we evolved our NGS platform to be able to sequence the virus and to be able to sequence it rapidly. And once we started that going, and that was sort of routine for us, then we also were able to do some sequencing training for colleagues in neighboring countries and to sequence some samples from neighboring countries. And this is some of the countries that we've supported over the time and that we've sequenced samples. At the same time, or actually a little bit before this, we had started doing seroprevalence work. We did the first seroprevalence work in Ghana, and I think it was probably one of the first in Africa, looking at trying to estimate the population level exposure of to the virus. And we started this in August 2020, and that was when we were able to see in 2020 that unlike what we expected based on clinical cases and clinical what do you call it, PCR confirmed cases, we actually had a high level of population exposure to the virus SARS-CoV-2, and we basically evolved. Hello? Okay. So we basically, and this was work that we funded using funds from other projects. We were able to divert some funds to do the initial work. And based on the evidence that we got from this, and we showed that, I shouldn't use the term diverted, but we had funds that we got permission to use for this work. We repurposed, that's the term. So once we had the preliminary data, then we were able to get funding from Rockefeller Foundation to really spread this to Burkina and Nigeria. And we showed that during Delta, for instance, we the spread was so rapid that we had up to almost 50% seropositivity in the population. And this is still, and at the same time in Nigeria, they had about 50% seropositivity. So this is part of the... Okay. Anyway, and then we, at the same time that we were doing that in Ghana, we had partners in Nigeria and Burkina that were showing that Nigeria has similar seropositivity to Ghana, and Burkina had lower seropositivity. Sorry, apologies. So we showed that based on case counts, Burkina had about half the number of confirmed cases of Ghana and Nigeria, and we're able to show that that sort of correlates to the level of exposure. Sorry, one minute, I have to. Okay, I'll move on from this slide. So the take-home message from here is that we showed that with each wave of infection, seropositivity rose to the point that by Omicron, we had about 80% of the population fully exposed, and we've since followed up, and we've seen that we still do tracking in Ghana at least consistently. We've seen that it's sort of steady state around 70%. And then another thing that we did, because early on we built up a bank of clinical samples, and we also built up a bank of blood, well, not blood, but plasma and PBMCs. And we used some of our samples to validate and optimize a nucleocapsid ELISA for use as antigen testing, for antigen testing. And we were able to show that this was at less than $1 a test, you could get similar sensitivity and specificity as the commercial RDTs. And this was very important at the time we were doing this work because IDTs were very expensive in Ghana, and so we were exploring this as a way to actually be able to track, to do mass screening of people to see what's the real infection rate at the time. And this is just showing some of the data. This was done with colleagues at Southampton, and we were able to show that the performance was very similar between Ghana and Southampton. There weren't very many negative samples there, but we had very similar performance between the two sites. And then I mentioned earlier that we had blood, we had plasma, sera, and PBMCs. So we wanted to also understand why SARS-CoV-2 infection was reportedly mild in Africa. And that was something that was being disputed back and forth. So we basically probed the plasma to try to understand whether there are any factors that would correlate to mild COVID. And we divided our participants into asymptomatic, symptomatic, and then we looked at the cytokine profile. And we had some non-survivors in there. So, and this was work that we did, I think we did it in early 2021. And so it was still quite relevant at the time, that we saw that unlike the reported cytokine storms that has been widely reported, even in our symptomatic cases, we didn't have a very high expression of IL-6, interferon gamma, IL-8, unlike had been reported in Italy, for instance. And then we saw that in those few cases that actually died, they did have evidence of cytokine storm. So the takeaway from that paper was that one of the reasons why we have mild COVID in Ghana and probably West Africa is because we have attenuated cytokine response to infection. The reason is why. And so to try to understand that reason, we did some PBMC analysis to basically to see whether there's a T-cell response that's helping to fight this virus or not. And this is using peripheral blood. So we compared again symptomatic and asymptomatic cases, and we're able to show that the symptomatic cases always had more T-cell activation and evidence of exhaustion, which has been reported for other places. But the key takeaway is that it's always about the proportions, right? We have more asymptomatics than symptomatics. And if you, oh, I do have a random slide there. Okay. Okay. And then we tried to understand, there was a hypothesis that maybe Plasmodium exposure was linked to this attenuated cytokine responses. So we tried to look at whether there was a correlation between the levels of antibodies of Plasmodium surface protein, antibodies to Plasmodium surface antigens, and COVID-19 severity. Okay, I don't think that slide is supposed to be here. But okay, you have to trust me when I tell you that. What we saw was that there was a correlation. So in asymptomatic individuals, they had higher levels of antibodies to 4, well, we tested 5 to 4 surface antigens, which are indicative of recent malaria incidence or recent Plasmodium exposure. And in the symptomatics, they had a lower level of these antibodies. So then we tried to see if there was a correlation on the cellular level in terms of T-cell activation and exhaustion. And that's what I'm showing here. And 1 second, let me just check something. Oh, there's 2 slides missing. And so what I'm showing here is that, yes, we did see that there's a higher level of activation in symptomatic patients, and sort of higher level of TNF-alpha, interferon gamma in the symptomatic patients compared to asymptomatic patients. And it's actually quite a consistency between when you're looking at stimulation with Plasmodium, and for this experiment we used we used the actual parasites to do the stimulation. And it's consistent whether you use that or you use live virus or you use SARS-CoV-2 antigen. Unfortunately, I don't have those 2 slides here, but it's pretty consistent. So in short, what I wanted to present here is just some snapshots of things that we're doing at WACPIP, which is building a rapidly expanding research pipeline. We developed an antigen ELISA. I didn't present the antibody ELISA, but we also developed an antibody ELISA both for SARS-CoV-2, and we developed a pseudoviral assay, which we've used and validated for Delta, Omicron, and D614G. And we're still tracking and sequencing SARS-CoV-2. We're building capacity for sequencing other viruses such as HIV and monkeypox and hopefully Lassa. And we showed that the SARS-CoV-2 situation in Ghana evolved very rapidly. In fact, we were the center that was usually detecting all the variants as and when they came and advising the presidential team on, okay, Delta's here now, and things like that. And importantly, we've shown that there may be attenuated T-cell responses to SARS-CoV-2 infection, and potentially that's because of malaria. And we're investigating this further, doing single-cell sequencing. And one of the ways that we're able to move rapidly is also because we focus a lot on training. And currently, right now, there's a single-cell sequencing training workshop ongoing at WACPIP. And I have to highlight, I realize I don't have an acknowledgement slide here, but there's a lady in the back there called Keseho Tapela who did a lot of the flow cytometry work, and I think she has an oral. She's a WANIDA fellow. She has an oral later, so you can ask her all the difficult questions. And I have someone who, there's a few posters from my group here, so it'll give you a snapshot of some of the stuff that we are doing at WACPIP. And we are really trying to look beyond COVID, right? And so we're developing a I don't want to use the word pan-virus, but like a multi-virus platform to be able to screen environmental samples, screen plasma for neutralizing antibodies, and basically to try to preempt what's the next thing that's going to cause the next pandemic. So that's the sort of development projects that we have ongoing now, at the same time that we're trying to really understand what's going on in terms of immunology. I was not trained as an immunologist. I mean, I did pretty well in immunology, but I never considered myself an immunologist. But I have become more and more go in that direction. And so I'd like to thank our funders. The work I showed here was mostly funded. Part of it was repurposed funds from Crick African Network and FCDO, Rockefeller Foundation, and the Bill and Melinda Gates Foundation. That's currently funding a lot of the work, along with Wellcome Trust. Thank you very much for your attention, and I'll take any questions.
Thank you very much for this presentation, which provides us a very interesting overview of your impressive research you are conducting at WACPIP. So this is and the perspective also Thank you, and I hope, there is some question, please.
Thank you, Mr. Peter, for that good presentation. Within West African continent, I've never seen around here that have done thorough work in the area of COVID-19. There is this mystery that up till now I've not been able to understand what really happened, that the impact of COVID in Africa was less compared to other continents. Considering our weak health system, our vulnerable health system, there was fear when COVID was coming 2019 that the mortality and then the morbidity in Africa will scale the world. But unfortunately, we don't really know what happened. From your probing so far, can you be able to tell us what really happened? What really happened?
Okay, I guess what I take you're asking that we thought the impact would be devastating and it was not. So what happened? So that's what we are trying to understand, and I've shown a few snapshots of it here. My hypothesis is that it's multifactorial. It's obviously people always talk about the age thing, but you know that it's more than age. But what we've seen is that there's a mixture of genetic. I didn't show it here, but we've done some site-directed mutagenesis of the ACE2. So we've created some pseudoviruses, which and then we've put into those pseudoviruses. We've done different pseudoviruses with mutants which are supposedly highly expressed in the African population. We've done the infections, and we see that they tend to reduce the infectivity. Of course, this is in cell culture, so you have to take it with a grain of salt. We even did TMPRSS2 variants, and we saw the similar thing. And so it's partly genetic. The other genetic component is that we have a very high proportion of our population being having blood group O, and in some of in our plasma analysis, I didn't show it here, but we see that there's a trend to blood group O being more asymptomatic than symptomatic, and there's been papers published on that already. And then, of course, the immune component. I mean, that's also an immune response. Then basically the main thing we think is driving this is just exposure to pathogens that have an immune modulatory effect. And somehow, especially with malaria, there's this need to protect the body by not overreacting to recurrent infections. And so then you have the cytokine attenuation, and so when there's a new infection, then it doesn't overreact. And so that's what I'm thinking is the reason, the main reason. But it's multifactorial, and I think it was a perfect storm for us. I don't know if it's always going to be that way, but in this case, we had the right conditions to be protected. So the governments were taking, especially our government was taking a lot of credits for it, but the truth is, when we did our first seroprevalence, when we did our first sero survey, and we showed that in Greater Accra it was like 20% exposure, was like big news, because people were calling me to shout at me because it was going against what they were saying, that, oh, we're controlling the virus. But what we were really showing is that we were not controlling spread. It's just that we had a biological protection.
Thank you. Yes, I think I'm very sorry, just a last question, very quickly, please.
It's an immunology question, sorry. If you don't want to answer it, I can find one of you guys to answer it.
It's fine, I'll try.
You talk about attenuation. Do you really mean attenuation? Because what you're measuring is the percentage of the cells in the periphery that make X. You're not talking about the immune response that's actually happening. And it might be that it's, to use your own words, getting repurposed to do something else in the spleen or wherever.
So that's an interesting thing. John Sandy, who's here, who's a student I co-supervise, has done some sequencing at the virus host interface. And I think he'll have an oral. And he doesn't see, so basically, in that case, at where the virus, the infection actually happens, we seem to have a heightened response, but it's a heightened antiviral response. So that's why we now perforate everything. We put in the caveat that peripheral blood, because it was something that Yao always talked about, that what we see in peripheral blood, we see, let's say we see depleted B cells. That might be because they're where they're supposed to be. Or T cells, that might be because they're in the spleen. So the challenge we have is that peripheral blood is what is very easy to get. And so I still don't think that it takes away from the results. It's just the interpretation is a bit more nuanced and not very straightforward.
Thank you. I'm very sorry we are late, so I think we have to move to the next presentation. So I'm pleased to welcome Dr. Umar Yunusa. He is lecturer at the Department of Nursing Science at the African Center of Excellence in Population Health and Policy in Nigeria, and he will tell us a success story on using mobile phone text message to complete routine immunization in children in Nigeria. Thank you.
Okay, good morning all. I would like to start by appreciating WANIDA for allowing me to present the findings of our study. Our study is titled Effect of Mobile Phone Text Message and Call Reminders in the Completeness and Timeliness of Routine Childhood Immunization in Kano State, Nigeria. The United Nations Interagency Group for Child Mortality Estimation reported that about 15,000 children under the age of 5 years die on a daily basis as a result of diseases that could have been prevented by routine immunization. This is globally. This figure is higher in sub-Saharan Africa, where it's reported that there are about 78 deaths per 1,000 live births. As a result of deaths due to routine childhood immunization or diseases that could have been prevented by routine childhood immunization, the WHO in 1974 launched the expanded program on immunization. The aim is to ensure that all children who are eligible to get immunized get and benefit from childhood immunization. However, despite this innovative and initiative by the WHO, a significant proportion of children are dying, because the Center for Disease Control and Prevention in 2019 reported that a child dies every second as a result of a vaccine-preventable disease. And this figure is even higher in the low and middle income countries. In Nigeria, the Nigerian Demographic and Health Survey conducted in 2018 and published by the National Population Commission reported that about 30% of children in Nigeria received all the basic vaccination, and with about 1/5 of children not receiving any vaccine at all. So you can see all the work we do in the lab, if you finish, produce the vaccines, and people are not utilizing it, then it will be a problem. So the report stated that 1/5, that's 20% of children in Nigeria did not receive any vaccine. When you come to Kano State, only 30% of children were fully immunized as at 2019. That's the last Nigerian demographic and health survey in Kano. And a lot of reasons were given for non-immunization: vaccine hesitancy, skepticism, low level of awareness among parents that are supposed to get their children immunized. Then we have the low level of education, and some parents just refused to get their children immunized, where many forget. They want to get their children immunized, but they forget to get them to the facility to get them immunized. So this study capitalized on that aspect, trying to remind parents who wants to immunize their children, but due to one reason or the other, they forget to get their children immunized. So the study capitalized on this and reminded parents on getting their children immunized. This was done based on the reports by Gavi through the International Vaccine Access Center, IVAC, which reported that one of the procedure that can be used to get people immunize their children is through reminding them about the immunization of their children. And with this, we need to use a mobile phone to get parents immunize their children. And findings have showed that there is a widespread use of mobile technology. And this has shown to be very effective, especially in resource restricted setting, resource constrained setting. And hence, this study was conducted to examine the effect of mobile phone technology in the completeness of childhood immunization. Completeness is getting children immunized with all the basic routine vaccines. So this study was conducted in Kano State, which is in the northwestern parts of the country. A post-test quasi-experimental research design was used for the study, where women who take their children to be immunized for BCG vaccines were recruited to participate in the study. But for a woman to be recruited to participate in the study, she must have given birth to a child who is less than 3 weeks old, that's 21 days of birth, and she has a mobile phone or have access to a mobile phone and is willing to receive the reminder. So these are the categories of women we included in the study. Kano State has 3 geographical regions, territorial districts: Kano Central, Kano North, and Kano South. So we picked, randomly selected 2 local government areas from each of the 3 senatorial districts. And in each of the local government, we selected a healthcare facility to where we recruited the eligible women from. And after recruiting them, 6 of the facilities, 3 of the 6 facilities were assigned as intervention group, while the other 3 were assigned as control group. For the participants in the intervention group, mobile phone reminders were sent to them 3 days to the day in which their children are due to be immunized with pentavalent vaccines, and on the day they are due to be immunized. So 2 reminders were sent before the pentavalent vaccine 1, which is given at the 6th week of birth. Then the second dose is given at the 10th week, and the third dose at the 14th week of birth. So two reminders were sent to each of the eligible parents. Then immediately we track them. The first track, and they don't get their children immunized, we remind them through a phone call to ensure that they take their children to get them immunized. And after that, we follow them up to see if they actually immunize their children. Findings from the study showed that out of the 554 parents we followed, we had 13 that we missed, we have a total of 541 parents that completed the study, and 2,493 SMS reminders were sent to the participants. Findings showed that most of the parents were within the age of 25 to 34 years in both the intervention or the reminder group as well as the control group. This is likely because this is an active stage of the reproductive age of the women, where the most women are supposed to have gotten married and are actively giving birth to children, and the children that need to be immunized. So in terms of marital status, nearly all the participants are married in both the treatment and control group, and most of the participants had between 1 to 3 children. And for the children, most of them were between 8 to 14 days at the time they were recruited to participate in the study. There is no significant difference between the male and female population of children who participated in the study. In the intervention group, majority of the children were given birth to at the health facility compared to the control, where majority were given birth at home. So findings from this study showed that for pentavalent vaccine 1, we had 77.4% of children that were followed that were immunized. No much difference was recorded between that group and the control group. But by the 10th week of birth for the pentavalent vaccine 2, the second dose, there was a significant difference, because in the intervention group, we had 68.3% of children being immunized, while only 48.9% were vaccinated in the control group. And for the pentavalent vaccine 3, we have 60% of children in the intervention group being immunized. That's with pentavalent vaccine 3, while only 51. Then for the 3 vaccines, first, second, and third doses of pentavalent vaccine, we have 59.4% of children being completely immunized, while 34.1% of children were immunized in the control group. So between the intervention and the control group, we have an increase of 25%. So mobile phone reminder increased the level of immunization by 25%, but this is still low compared to the standard set by Gavi, whereby children, to get herd immunity, you need 80 to 90% of children to be immunized. Not just reports by Gavi. This figure is much lower compared to similar study conducted in the southern parts of the country. So this needs to be looked at for future studies. So this study concludes that mobile phone reminder is effective in improving the completeness of childhood immunization, and future studies should determine the appropriate number of reminders that should be sent to the parent to get them immunize their children. However, apart from reminders, because despite our reminders, we still got just 59%. Possibly other approaches need to be put together to ensure that parents get their children immunized with age-appropriate vaccine. So I would like to acknowledge the support provided by Bayero University, Kano, Directorate for Research, Innovation, and Partnership for sponsoring this study to be conducted. This work has been published by Journal of Pediatric Nursing, the Elsevier. These are other members of the team who participated in the study. Thank you.
Thank you very much. Is there a question? Yes, one question here.
Thank you, Doctor, for the presentation. My concern is the your study area.
Yes.
Considering that majority of our population reside in the rural areas where some of this network accessibility is usually very difficult sometimes, what other means do you consider, aside the text message where there are no network, that can encourage this vaccination, aside using text message or phone?
Okay, thank you very much. I think text messages doesn't require any, once there is a mobile phone, it don't require internet. Once there is a mobile phone provider, MTN, you don't even need an app, just a simple text message. I think most parts of the country have this access to mobile phone network, but not the internet network, even in the rural areas. The only issue that we recorded in the study is that of electricity. Some places may not have access to charge their phone, so possibly at the time we send the reminders, there is no light or something to receive the message. And also maybe the network, but in another way. We had a significant, initially when we started, a significant number of the message we sent were not delivered. So we had to use another means to ensure that they actually receive the message we sent to them. But apart from the mobile technology, other approaches need to be implemented to ensure that these women get their children immunized. In Kano State, the government is doing a lot, trying to educate people on the importance of getting their children immunized through the involvement of the community leaders and others. And because when you compare, despite that it is low, we had 34% of children being completely immunized, which is the same with the National Population Commission NDHS report of 2019. This figure was significantly high compared to the last NDHS report that was conducted in 2013. That's 4 years interval. Those that completed their vaccination in Kano State were just 10% out of 100. And it increased by about 24% in 2018. So the role of community sensitization was also important. Then there is this importance of educating the people, getting a reasonable population educated. Because at the end, we realized that education was part of a major factor, level of education, to ensure that even if people are reminded, they actually abide with what they are reminded to do. Thank you.
Thank you. Yes, a last question, please.
Thank you so much for the talk. It's actually a great public health concern you're trying to address. You mentioned you sent out over 2,000 text messages.
Yes.
How many call reminders did you send, and how did those call reminders affect your results? Because you are making this based on you are making your conclusions based on the text messages you sent. And the other question is that in other jurisdictions, like in Ghana, we have community-based nurses that go around to do childhood immunizations. So as part of the other alternatives explored by the health authorities in the Kano State, do you have some of these alternatives that you explore in Nigeria? Thank you.
Okay, thank you very much. Regarding your first question, the major intervention we used was actually the text message. We sent text message to all our research participants, those that participated in the study. The reminders were sent only to participants who did not immunize their children on time. That's at the point they are supposed to immunize. When we go for the first tracking, if a child is supposed to receive a vaccine by next week and the child did not present to the facility, so those are the specific participants we call to see that you are supposed to be in the facility today, but you did not come. So bring your child to get the child immunized. So it's not as much compared to the text message. Then in your other aspect of the question, we have similar things. We have what is referred to as the immunization outreach, where community health workers go to hard-to-reach area to immunize children. And we have what is referred to as the immunization plus days, whereby apart from the normal routine immunization, some people move around from house to house to but that's usually specific for some specific vaccines, or when there are outbreaks, like the polio is done usually for polio vaccines, or when there are outbreaks of maybe cerebrospinal meningitis, not specifically for pentavalent and other vaccines, but outreaches assist in the routine vaccines. Thank you.
Thank you. I think it's time for the coffee break, so I just invite you to continue the discussion during the break.
Right, thank you very much, Sylvie, for chairing this section for us. It's time for us to go for coffee break. I know we are a bit behind time, so instead of the 30 minutes, we'll do a 15 minutes coffee break. So you grab your coffee and then you either come into this room or the other breakout room. So either you'll be here or you'll be in the anesthesia room, which our protocol team will direct you to that particular room based on the program, wherever you want to be, and then you select and then you go there. Thank you, and just interact. All the questions that you have, you could address it to the speakers as we interact and have our coffee break. So yeah, thank you. And please leave your devices behind. Don't grab them with you. Just leave them right on the table or on your seat, and then you come back. And to the other room, we'll just bring it there as well. Thank you.